Hi, folks. This meeting is to discuss the current state of PR 3306 in Rook, where I am proposing the creation of what is now called a storage class device set. Travis, do we want to go into a brief overview of what I'm proposing and then dive into the discussions?
Yeah, and I don't know if we need to share your screen yet, but when we look at the PR, we can certainly do that.
So I'll
Do you want to
just
give the overview, or I could?
um go ahead. I'd like to hear where you think the design is today.
Sure. So with running Rook in dynamic environments in particular, or even places where you're using the local device provisioner, we basically want to base all of our state on top of PVCs and do it in a Kubernetes native way. So this will give us the advantage of being able to run in AWS, for example, where we want to run Mons and OSDs on top of PVCs. That will dynamically provision an EBS volume to be the backing store for us, rather than using our famous data host path, which is tied to a node, and other implications. It's not done in the Kubernetes native way. So PVCs being the Kubernetes way of doing things, and come with all sorts of benefits to run based on local storage or in cloud environment. So with that will come some design changes, of course, primarily around Mons and OSDs. For this meeting and for this initial design, it's focused around OSDs, and Mons will follow a bit later. But overall, I mean, the design is really in the cluster CR. We specify what or how much storage you want. For example, give me three devices that are 5 terabytes each, and use this storage class to provision them. And then the operator can go and create the OSDs based on that information. The operator can make sure they're spread across domains, or according to whatever's in the cluster CR, to make sure the OSDs are started properly. The operator would start up or create a PVC, start the OSD prepare pod for each individual PVC, and then based on the results of that prepare pod, start up the OSD daemon, which will follow. So this follows the same pattern we have today as far as creating OSDs. The main difference being that instead of starting the OSD prepare pod based on each node, it'll be based on each individual PVC, which are not generally tied to a node. So that's a bit of an overview. At a high level, I guess, maybe questions about that. Or Jose, any major gaps you want to fill in before we go on?
The other thing I'd mention is that this is a slightly different way of thinking about storage clusters, Ceph clusters, and thinking about how storage is managed. In particular, these are called storage class device sets because devices, we don't care so much about the exact identity of volumes provisioned via storage class. They should all largely be identical and interchangeable. In the implementation, obviously, we need to maintain coherence so that a PVC is always running a given OSD pod, is always used by a given OSD pod, but both that pod and the PVC should be able to move around the cluster based on various constraints, either from the cluster itself or placed on the OSD pod, or even from the PV itself. So there are various layers that you can implement to control how the OSDs get spread across the cluster. And I think that's the only thing I wanted to add there.
Yeah, and one thing we definitely want to consider is, Blaine, your changes around OSDs that you're working through refactoring and redoing the configuration there. We want to coordinate closely to make sure we don't stomp on each other, because we're talking about a sort of a different way of launching OSDs, well, a very different way of launching OSDs, which will use the prepare pod and start daemon pods. But anyway, we'll have to look closely to make sure.
In some sense, I think it might make sense to implement this in the new code path. Especially like since we're talking about deprecating the old code path sort of entirely. And so we either design this for the existing code path and then alter it to fit into the new code path, or we design it for the new one from the start.
Right, and since we don't have the new code path in place, I guess it's not clear how we would start coding now on the new code path, but if there are design principles we can piggyback on.
Yeah, I personally do not want to establish a dependency on waiting for the design of the new code path to finish before we can start implementing these things.
Yeah, I mean, I don't think that's wise either. It would probably be good to just keep up with what's going on in order to design things so that it'll fit more easily into the existing path.
Yeah, as long as the developers can keep up with the ongoing discussion of the new design, that should be sufficient so that they can be mindful to implement things such that they can be refactored more easily afterwards.
Yeah, cool. That sounds great.
So, Jose, do you want to dive into more of the details of the design now? Maybe we walk through the design doc, or
sure.
I don't know what would be most useful. Yeah.
So I will start sharing my screen here. Entire screen, allow. All right. Do we see the doc?
Yes.
All right. So I'm not going to go through this verbatim. I'm just going to go straight to the struct. There was a request from Jared to make this something that can be reused across operators in Rook. So I've taken some care to design the actual struct itself such that there are no dependencies on things in Rook-Ceph. And then other operators can just use these however they wish. I feel it's generic enough as it is to allow for all the functionality we want in Rook-Ceph. So I'm just going to go over it real quick. The storage class device set will need to have a name to identify it. In particular, this is so that we can easily keep track of which devices are controlled by which device set, especially for the purposes of deletion or deprovisioning of these devices. Since storage device sets is just a list of storage class device sets, there would currently be no way to track which device set is which, since we should not rely on strict ordering of the list for identity.
Right. So what this translates into is a label with that name on the PVCs or the OSDs or and everything. That's easy to translate into a label.
Yep. So it's easy to implement for PVCs. So then we want a count of how many devices there will be in this device set. As mentioned, storage class devices in the storage class device set will all be largely identical. I say in air quotes. For the majority of use cases, this will be true. So each device will be provisioned with the same capacity and configuration options against the same storage class. However, in the case if we're using local PVs, the capacity of a given PVC is irrelevant because there is no provisioning, no dynamic provisioning happening. So whatever local PV gets bound to the PVC, we just have full access to the capacity of the device.
Wait, so are you saying for some types of PVC, we need a size and some we don't, right?
Right.
Like if we're in AWS, so where are you saying we would put the size parameter here?
In the volume claim templates field. So, yep. So to keep going down the immediate list, we have resources, which is for resource requirements for CPU and memory, requests and limits there. This is to allow an operator to figure out how much their devices will consume in Kubernetes. And in our case, these will be mapped directly to requests and limits for the OSD pods. Placement is just a replacement. Oh, go ahead.
I do have some questions about the resources and placements in that, like, obviously the disks themselves don't have CPU and RAM on them, and the disks aren't really placed when they're PVCs. It's only if we genericize this, it's only whatever application is consuming or controlling the devices that actually has those. And within Ceph, we already have these for OSDs, and I'm not sure this is something that belongs in a disk.
I want this in here because the current Ceph-Rook model is that it allows multiple places to specify resources and placements, with each lower layer overriding any configuration in the upper layers. So I want a place where all OSDs in a device set can be configured in one place. And that if you have multiple device sets across the cluster, you can have different configuration per device set.
And so I think, Blaine, maybe what answers your question, at the top level of the CR, you can specify resources, and OSDs specifically, you could specify resources there. And these device sets should inherit those settings. But this just gives a way to override the resources for this device set, I think. But it's not required to set here, or no reason not to inherit.
Yeah, and if some other operator...
Oh,
go ahead.
Are we assuming that these device sets will cohabitate with the normal disk-based model? Like, if these device sets aren't going to be used at the same time as our existing device-based model, I don't see why this would need to override any other settings.
Because, for instance, and I'll get to this, you could have one device set that only has one PVC per OSD, or you could have another device set that has multiple OSDs per storage device. In which case, or you could also have and a device set where an OSD has multiple devices. And in each of those three cases, you may want slightly different resource requirements for each device in its set.
And Blaine, or just to clarify, I'm not sure if we're talking to the same point. So the resources here are about resource limits and requests on OSD pods, right? That are started with this device set. So if those limits need to be different for some reason because of their size or whatever, that's different from this device set from what the other existing OSDs are using, or the previous way of doing it. Are you asking why these would need to be different, or why specify here if you can specify at a higher level?
Correct. I'm trying to understand why disk specifications would need RAM requests, CPU and RAM requests.
Again, this is the notion of a device here does not strictly map to an actual disk. This is an abstraction for how an operator wants to view a storage device. And in our case, a storage device is and for RookSef, this is a combination of OSD pods and actual underlying storage devices. That is what we're describing as a device in this device set. It is both the storage device and the software managing that storage device.
I'm also pretty confused. Could you give an example of like where this would represent not a plain disk?
I mean, in RookSef, if you just specify a plain disk, it does nothing. You have to put an OSD on it, right?
Sure.
This device set does both.
So it also represents OSDs?
Yes.
Okay.
So I mean, whether the devices are specified with the current way or whether it's the device set, you're providing devices that will put OSDs on, and those OSDs can have resource limits and requests.
But I mean, currently today, we don't actually have a way to handle the problem which is being posed here in Rook. Like we can't set different OSD like requests and limits for the various devices we would find on the operating system that might be NVMe versus spinning disk. And so it seems to me like a device set really should just be a set of devices, and we should figure out how to handle the case of resource requests being different for different disk types at the level of the OSDs, where it can also apply to physical disks.
But this can also apply.
One of the reasons I'm saying this is because I know there was a pull request I looked at semi recently that was someone adding in a feature for priority in addition to resources and placement. And I don't know that every time we add a new Kubernetes feature like this, priority was added in Kubernetes 1.14, and it's only a matter of time before someone wants priority in this, and then wants the next thing and the next thing and the next thing also defined in this, and that's just more layers all over the Rook code base where we have to define those things.
Right, but RookSef already has the model of allowing you to specify and override OSD configuration at different levels. This is keeping that model.
But we can't override it at the disk level, unless I'm mistaken.
I mean,
and this would mean overriding the config at a sort of virtual disk level. But if we just had these as disks and we could override OSD configs on a per disk level elsewhere in the cluster CR, then that would be, I think, a more robust solution overall, because that would help us with like physical devices as well as these claimed devices,
So the
without having to implement placement and resources and priority. And like I said, I mean, this list seems to just keep growing. Also, no, never mind. But I think we should still revisit the reason why resources and placement are in here, and consider whether that is something that like people actually need to override today, versus just setting some basic OSD requests. Like how many clusters are actually going to need to make use of this? And I doubt, like I kind of doubt it's that many. And
Yeah, I would really. Oh, go ahead, Travis.
Yeah. So are you asking, Blaine, why we would need this override, and why not just have them specified, the resources specified at the top level of the CR?
Yes.
That's what you're asking?
Right, because that's the only thing that we can do today.
Well, so there is a pattern already of being able to override at different levels in the storage CR. So you've got the top level
I
of
understand
storage,
that.
right?
But we cannot override on a per disk level. We can override on a per host level, and that's it.
Well, this isn't per disk. This is per device set.
Right, but that essentially translates to per disk. Right, because each OSD which runs a disk from this set will have these, which means.
But isn't that the case?
Following...
Doesn't that happen now, where like each OSD pod is configured exactly with the resources and placements that are specified in the cluster CR?
For that node, yes.
Yeah.
Like we have a granularity of the node level for physical devices, and so this is introducing a new specification for devices, which also includes CPU and RAM resources, which means that whenever this is implemented, those overrides will then proceed to go to the down to the disk level, but only for this specific usage, only for the storage class device sets. And from a philosophical standpoint, I like when I think about devices, I don't think about them having CPU and RAM. And if they are effectively virtual devices, they aren't actually anywhere. They're just they just are. And I think that's something that we should be considering, and consider whether these resources and placements specified down to this.
Then I can take the and then level. I can take the word device out of the name. All I care about is that this represents a storage device and the software required to run it in the cluster. I can take the word device out of the name if that'll make you feel better.
But I don't think we need to know about the software that requires to run it in the cluster either. I don't think there are really any users who are going to need to make use of resources and placements that are different for different device sets, that couldn't just be achieved by setting the OSD resources and placements in the Ceph cluster CR that we have now.
I have a requirement, for instance, in AWS to support different storage classes with different types of EBS volumes and different capacities.
Is that like saying that you can't put a certain type of EBS on, like, say, a small instance? Like you have a small instance in EC2, it won't support a certain type of EBS volume?
If you have an instance that is too small to handle the resource requests for a given device in a device set, that OSD, pod, and PVC will not be scheduled on that node.
I see. So it's not about the resources for, like, say, the OSD per se. It's for the resources for actually getting the volume mounted.
And for getting the volume mounted and running the OSD pod against it.
I think the last.
Okay, so this is
Gotcha.
also requiring users to understand, like, this is requiring the experience of Ceph power users effectively, the people who understand that different device classes even have different like resource requirements.
Yeah, and I want to.
From like what we were seeing at KubeCon, that was not something people seemed to like be aware of.
And that's fine. I want to leave this open to Ceph power users to do what they need to do. The resources and placement fields are not going to be required fields to specify a device set. They are optional. So you can optionally override the settings you have in your broader Ceph cluster.
I still think it's better to leave these out initially and consider if there's a way that we could design that like device level granularity into a different part of Rook that wasn't a specification for using a set of claimed devices.
I'm willing to look at a counter proposal that's written down. I don't want to remove this without a plan of how to do it elsewhere.
So a key point here I'd just like to make is that at the end of the day, whatever resource limits are specified, they are applied to a single OSD daemon pod, right? However, if they're specified at the top level, or if we support some level of overriding or whatever, at the end of the day, we end up with one one resources definition that's applied to an OSD pod. So our examples and users will commonly only specify it at the top level, if they even specify it at all, right? But if we have some overriding scheme for power users, we already have that pattern in place, and it doesn't. I'm not seeing the complexity that's really being added here.
I see the maintainability being a challenge, because, like I said, we've gotten a PR recently to add priority, which adds next to placement and next to resources, and every time we get some new feature like that in Kubernetes, we have to add it. Like, I could ask, why is priority not also in here?
Right, and it would probably follow the same pattern we would need for resources and placement and whatever other type of thing that Kubernetes adds in the future. We would need to support it if we want to support it.
And every single time we have to add these. Like, I am also, like, I'm trying to point out here, like, this. I mean, that issue is an issue that we have in Rook, and to me, it seems like a problem because we're always trying to play catch up with what Kubernetes has.
So is
that the nature of running on Kubernetes?
Right.
In a way, possibly. But is that something that we need to do? Can we get those things without having to have specific like notations for them in the CRD? Can we design this such that they're just pass-throughs?
Well, I do have a field right after that label named config, which is just an arbitrary map of string to string.
Right, that doesn't cover these more complex types, really, though, or which have a whole, a whole schema for defining them. So, would it be safe to say, though, that design change is outside the scope of this, because this is following the existing patterns we have? Yeah.
So this is following the existing patterns we have, and in particular, it fulfills a need I have in it. If you are willing to put up a design to fulfill the need I have, otherwise, then that's fine. I'll read it.
And so you have a particular need that you have different resource requirements and different placement criteria for OSDs of different types that are
For
created on persistent volume.
different device sets, yes.
Okay, so what is? I mean, what is that? I mean, I'm curious to know. Like, I
The
think
basic sample, the basic example is having a separate device set per Amazon AZ. I want a given device set to only provision EBS volumes and the corresponding OSD and schedule the corresponding OSD pods within a certain availability zone.
okay, and that's placement.
And that's placement. And then, you have to account for the fact that because of reasons, an admin might have different instances and different AZs. Thus, the resource
Right.
requirements come in.
Right, but the resource requirements are on like an OSD pod level, like that. Right. If I have a different node that doesn't, if I have a really huge node filled with a bunch of SSDs, each of those SSDs still takes the same number of compute resources as it does on a really small node with those same SSDs. Right. The resource requirements for the different nodes don't change from the OSD perspective.
Sure, but like
If the
that's
size
irrelevant to the
changes,
use case I was saying.
Sorry, say that again, Jose.
That's irrelevant to the use case I was saying. In my use case, there are no SSDs. It's just remotely attached EBS volumes.
Well, and so what I said is that if the size of the devices is different, you may want different resource requirements. But I don't know why you would create device sets with devices of different sizes just to be consistent. Although, we don't know what environments people will be running this in. So it doesn't seem like it would be common to use it. I agree.
But I'm always against the argument that we shouldn't do it just because it's not common, especially if the utility it provides is greater than how uncommon it is.
I mean, with that utility though, we also have to deal with users misusing it, whether it's a field that is undocumented or underdocumented.
Okay, and then if they come in, we provide the field for them to do, multiple things, but we document what use cases we officially support. And if they're doing something outside those officially supported use cases, then they're at the mercy of any developer that's willing to help them with it. Otherwise, the issue just remains open and untouched.
So I think there's some other high level concepts we need to get through as well. Could we take this question offline and discuss it on the PR, on the design PR?
Yeah, I'd love to see like maybe just a covering set of examples. Maybe it doesn't seem like we've hinted at more than like 3 or 4 different permutations, but that would be really useful for me. Put some concreteness to this abstract concept.
So just provide a set of examples in the PR of how these various fields could be configured?
I guess, and I think like maybe like sort of getting at maybe where Blaine is at is like, what are some of the examples where maybe the fields are unused or don't quite make sense for that scenario or something. I mean, I think this sort of makes sense to me, but maybe that would be helpful at like a higher level. I'm still a little unclear about some things that might clear up.
All right. I'm putting a task on myself to update. I can probably just update the the design doc itself with examples, since I have a section for Rookceph OSDs in there anyway.
That'd
Yeah,
be great.
thumbs up.
Seeing the YAML files. Yep.
All right. Ooh. So yes, that's what's there right now. As mentioned, there's a config field that's a map of strings to strings, which would allow you to just specify, in our case, generic OSD configuration. The one that comes to mind is OSDs per devices, so that in volume claim templates, you only specify one storage device, but you could have multiple OSDs for those storage devices.
It gets more complicated than that.
Yes.
So I'm caring about all the different orchestrators that we have in the Ceph ecosystem, and Rook is one of them. And to make the interoperability between these different orchestrators more working in a way, the Ceph project defines a data structure. It's called drive group spec, which very much resembles your storage device set.
Okay.
Tell you a link to the specification. It contains all the features that are supported by Ceph Volume, like having different drives used for different parts of the OSD. So the OSD supports data devices, it supports write-ahead log devices, or different sets of write-ahead log devices.
Okay.
And all the different features supported by Ceph Volume are covered in this drive group spec.
Right. That sounds like a great possibility for how to implement this under the covers. I don't see how it affects the design at this level.
The sub thing is a device selection, which is a selection of devices. Like, for example, it's more think of a set of devices on a given host.
Oh, okay.
Give me all devices from a specific vendor, or give me all devices with a specific ID, or give me all devices with which have rotational devices, or give me all different devices, or all the devices on a given host with a specific size constraint. And that's called device selection, which is a bit above.
Yeah, okay. Again, this sounds great for how to implement this under the covers. I don't see how this affects anything with the design at the level we're talking about.
Yeah, and it does seem like we need to do this at the level outside of the new design with PVCs. This is more of how do we know which devices to pick up, it looks like, based on different properties. So I'd like to, but it does seem independent from the PVC and DeviceSet design. But yeah, I want to look at that closer, for sure.
Yeah, the design as specified now with just this arbitrary config field would more than allow us to specify a configuration for a drive group. So I think that leaves the door open for either, initially or afterwards using drive groups for this struct.
We only should make sure that we are not working against drive groups. Yeah.
Sure.
There is also a set of examples from one orchestrator that already makes use of drive groups.
All right.
So as long as your proposal does not works with the drive groups, I'm happy.
All right. So can I ask you to take these links and this information you just said and comment on the PR with this. And if possible, raise any points where you see possible conflict with this feature. Otherwise, it'll just be good to have it in the PR so that any developers that go implemented later will be able to look it up.
Yep.
If you
So
want,
in which time zone are you?
U.S. Central Time.
Okay. Yeah. I'm based in Europe, so.
Okay. Oh, I can do you one better. If you are willing to write up the text in a PR comment, I will gladly insert it appropriately in the design doc.
Okay, perfect.
Cool.
Yeah. Overall, I mean that the drive groups look applicable to when we're looking at and analyzing devices on a node basis, where the PVC and dynamic provisioning change, since it is dynamic and will be done on an individual PVC basis, it may not be as applicable. That's my current perspective, but let's follow up offline.
We could also see it in a different way. We could enhance the drive group specification to also include PVCs.
Yeah.
Right. Add the dynamic nature of that. Yep.
I'm not sure. I mean, while we could do that, I'm not sure that that's the best idea. I mean, that is very like Kubernetes specific, and I think that I mean the whole thing with the orchestrators is to abstract Ceph from things like that. I think it makes a lot of sense for the drive group specification to perhaps have some place in the existing OSD specification. I'm not sure about these device sets just because of the nature of what they are and how they work. They really do seem to be a domain of their own to me.
Right.
Yeah, I'm not saying that, at least for an initial implementation, I'm not saying we should, purely go with drive groups or, take them into full account. But allowing for drive groups to be brought in later sounds like a good idea.
I'm not saying that we should do it immediately. I'm just saying that we shouldn't make things harder in the future.
Yes, correct. Full agreement. All right. So that covers just the struct of the storage class device set. Then we get into actual implementation of how this gets done. And here's where we have another major point of contention. Currently, as I understand it, OSD pods are managed by single replica deployments. I am proposing for this to introduce a notion of OSD managed by stateful sets. This is a somewhat major shift in paradigm and would involve, a new code path to generate and manage the stateful sets. But my argument is that all that effort and future maintainability is worth and preferred over needing to implement logic of managing these pods and PVCs as part of Rook. A stateful set would allow us to offload all this coordination and identity management into Kubernetes using a well-known primitive.
So how would that approach take into account multiple OSDs per pod? Or multiple OSDs per PVC?
Let's see. So my thinking was what would need to happen is that you would need to have OSD pods, multiple OSD pods mounting the same PVC. In which case, you would simply create a stateful set that specifies multiple OSD pod containers, since the OSD pods always need to be co-located with whatever node the device is on. So in this case, a replica of the stateful set actually includes more than one OSD container.
So creating the OSD, you're saying, would be done by an init container, and then the individual pods would be created based on that, right? So the number of pods in the stateful set would change based on what the init container decides needs to happen.
Correct. So yes, down here as the last quiet bullet point, I suggest that the current OSD prepare job be specified as an init container for the stateful set. Travis did mention that this would mean the OSD prepare pod container is running every time the stateful set replica is restarted, or the stateful set pod is restarted. But if I understand correctly, the OSD prepare job is currently written to just silently complete if Ceph volume detects there is already an OSD on the devices it is trying to prepare. So as far as resource consumption goes and time spent, it should be a fairly small amount of time if I understand the process correctly.
Right. That's not a major concern for me. I think changing the whole pattern of how OSDs are prepared and started is more of the concern. We know it works well for OSDs today. Stateful sets do work better with PVCs, admittedly, but what in the current pattern prevents us from continuing with that pattern with PVCs is really my core question.
Right. And as stated, best I understand the pattern right now, and pardon me for still being relatively naive about RookSeph, but the pattern as is would allow for using PVCs against the deployments, since it's just a replica one deployment per OSD pod. The thing that would need to change here then would be that you would, for instance, in the case where you have multiple OSDs per device, you would have to make sure that the relevant deployments specify the same PVC, and then we need to determine and keep track of PVC identity, separate from the deployment identity. And to me, that just gets real nasty real fast, and is a larger maintenance headache than letting stateful sets do it for us and maintaining stateful sets.
What kinds of issues might we run into with fighting against what Kubernetes sees as its policy for making sure that the stateful set has the correct number of instances of the pod? So I'm thinking about things like policies related to failing over OSDs and how we use various sort of hand-wavy semantics about timeouts and conditions. It seems like with stateful sets, we'd need to somehow figure out how to express all that stuff in X. I don't know what X is. Like, how would you have that fine-grained control? Or is that a concern?
I don't quite understand the question. Can you give me a specific example of a particular feature you're worried about?
I mean, I think failover like right now is something that is being worked on where we decide when to remove an OSD from the set, and you know, there's phases to it. You know, it's like, okay, we think that OSD is down. We're gonna, you know, we observe it down. We're gonna wait a while, then we actually delete it. And you know, would we have that fine grain control over the pods in the stateful set, or does Kubernetes see the world much more simple? It sees there are, you know, it sees count is 5 and we want it to be 4 for some reason. And it's not just that we want it to be 4, we want it to be the third, like the pod with a specific identity treated differently. Like it feels to me like stateful set documentation treats everything the same, and like Kubernetes would just be fighting against us when we wanted to. I guess my question is, it's not a specific example. It's more conceptual. Like, are there scenarios with stateful sets we're going to be fighting against?
All right, so let's see. Broadly speaking, in a storage class device set, you don't necessarily need to worry about the exact identity of a device in most cases. So, for instance, say you have AWS again, because, you know, I love it and I'm Red Hat. If you have a stateful set with replica 3 and and then it's a simple use case, 1 OSD per device. So you have 3 OSD pods, each mounting a single PVC. And say device 2 goes bad. Depending on how we want to do this, it is entirely possible, for instance, to just, or rather, Kubernetes itself, if the device goes bad and the software in the OSD pod starts complaining, will just try to restart the pod until it succeeds. If it fails, it goes into a crash loop and then stops restarting it after a while. At that point, we, either as an admin or an operator, depending on how fancy we want to get, could go and delete both the pod and the PVC as they exist. This means then that the device used by that OSD goes away, and the stateful set would recreate a pod and PVC to resume the identity of replica number 2 in the stateful set. As far as Ceph is concerned, this would probably be an entirely new OSD with a different ID.
Yeah, I think I think so. The way, you know, like you're describing this this functionality, and it sounds like when you're describing the functionality that you're really describing the semantics of handling failures from Kubernetes' point of view. And I'm just thinking like upgrades. You know, I guess the tension for me is that having really tight control over the OSD pods and their life cycle is really appealing in the current method, like the current way that Rook is working. And I'm thinking about things like, what if I want to, you know, do upgrades in a specific way? The stateful sets let me do that. So I don't know. This can be an offline discussion. It's just a concern I had.
Okay, sure. I can definitely see that. And, you know, going with my general philosophy of not artificially limiting functionality where possible, I can definitely see the argument for that. I suppose the tricky part would be, can we come up with a management scenario that a stateful set would prevent entirely.
Yeah, exactly. And we only need one, and I think it's worth exploring specifically for those counterexamples a little bit.
All right.
Well,
So,
if I
go
could,
ahead.
if I could go back to the OSDs, multiple OSDs per device example, I'm not seeing how this plays out with stateful sets because, okay, so we would create a stateful set for a PVC. We would say create one device for the stateful set. It would go dynamically provision and attach this PVC, create this PVC, attach it to the pod. It would run the init container that runs set volume, and we tell it, oh, create 5 OSDs for this device. So then that container is done. It would need to run the OSD container, and there's not an opportunity to create 5 containers based on that one init container, right? Every container in the stateful set would have its own init container with its own subsequent container to run the OSD.
Right, so real quick here, can a single OSD prepare job, as it is today, prepare multiple OSDs for the same device?
Yes, it's a single set volume command, and there's a parameter OSDs per device equals 5 or whatever.
All right, so at the time we're creating the stateful set, we define both the init containers and the containers that are going to be part of each replica in that stateful set. So we know at that point how many OSDs we're going to want per storage device. So you attach one PVC, you have an init container that's configured to create 5 OSDs for this one device it has control over, and then you just specify 5 OSD containers for the pod.
Well, wouldn't all of those pods get their own init container, which would all call the set volume command to create 5 OSDs?
They're not different pods, they're different containers in the same pod.
Well, so a stateful set creates pods. A pod has init containers and containers. So I don't see how the init container could be shared across multiple pods.
You only need to run the init container once. You just said it. The init container is the OSD prepare job. The OSD prepare job can run against the one device that is part of that replica, right? And it prepares 5 OSDs on the device. Then you simply run 5 OSD containers in that same pod against the one device.
Right, but we don't want the multiple OSD containers in the same pod. We want different pods, so they're running completely independently, and one OSD can't take down another OSD and kill the pod, for example. We want independent pods is the thing for OSDs.
Ah, I see.
I think even with independent pods, I'm not sure this is an issue. Like we've already talked about the prepare job being idempotent effectively. And unless I'm mistaken, it's been a long time since I've read the docs. Stateful sets are always sort of scaled up one at a time, which means that you would never have like 2 pods trying to run init container like OSD preparation on the same disk at the same time. And so once one of them does it, then that one is also like it's still provisioned for all of the pods that come afterwards. If my recollection is true.
That is true. They're scaled up one at a time. Good point. But so each init container would rerun the same set volume command, and or we would check, oh, it's already initialized and skip that step. But then another challenge I see is how would each OSD pod know which OSD ID it should start. So now we need to communicate between the pods, as opposed to the operator just generating it as part of the pod spec, and then.
Right. I mean,
Right.
potentially there could be some what's the word? Some like research that goes into that. I know Ceph volume, when you do an inventory, will report whether devices are locked. So we could be kind of asking the question when like when we do that Ceph volume inventory, do all of the devices get reported as locked, or like when the pods are like, fail and restarted, is there just like, do they just grab one of the unlocked partitions and run an OSD on that? And is that something we can do programmatically, which the way OSDs are run, maybe not. I'm not sure.
Yeah, I'm not sure how we would check the lock or whatever. So, one other consideration is, and reasons we have the one OSD per pod design is that so we can have the OSD ID in the name of the pod, and that's why we separated out the Ceph volume, or the OSD prepare pod, as a separate step, so the operator could see, oh, I know what ID you are, start the pod with the ID in the name of the pod. So it's really easy makes the troubleshooting a lot easier. And with the stateful set approach, we would not know the name of the pod when we create the stateful set. Or we would not know the ID when we create the stateful set, that is. So we lose that association at that level.
Right. A question. Ceph ignorant question. For a given OSD pod, or actually I should say for a given OSD process in an OSD pod, is it pre-configured with the ID of the OSD it's supposed to be?
Yeah, when the OSD process starts, yes, it needs its ID.
And then it goes look for that data on the device?
Right. And it knows like which LV to go mount if there were multiple OSDs per device and all that. Because there's a separate set volume activate command actually that sets that up for a particular OSD ID.
All right.
So you run, yeah. Anyway.
All right, so I'm having a crazy idea that I need to stew on for a bit, and I don't want to do it, live on a recording. So Travis, I'll ping you later to try and just bounce some ideas off you, see what you think about it, and then once I solidify that, I can bring it to a larger group.
Yep, sounds good.
Yeah, I mean, it also occurs to me that the OSD ID doesn't need to be known beforehand if the container running in the pod is not a specific OSD. If we went back to the kind of one of the old methods of running the Ceph daemons of calling a rook binary that then would wrap up the OSD. That binary could potentially do the device inspection and then run the OSD with the correct ID.
All right.
Yeah, so we'll follow up. And if there's general comments, I mean, we'll make comments on the design doc too, or we can discuss in the dev channel for general discussion, or we'll convene for this on a daily basis too.
Okay. So I think I've covered the major points on the design doc, and I think I've covered all outstanding design points that I'm aware of. Real quick, I forgot to write things down earlier, so I don't remember what I said I do. Currently, I have add drive group related text when it becomes available, and discuss multiple OSDs per device with Travis. I think I remember at least one more thing I said I do, but I don't remember what it is.
Examples?
Yes. Examples in design document. All right. Perfect.
Resources and placements.
Say that again.
Placements in the main structure. I think there was some impasse about that as well.
Yes. My current request is that someone, Blaine, I believe, yes, raise the complaint in the design PR and preferably provide an alternative design, even if just a rough one, on how to get the functionality I want. Because ultimately I don't care whether it's in this struct or not. I just want the feature to be available, and if the functionality to be available.
Right. I mean, I do see like your use case of wanting the different placement. Like I see that pretty clearly, and I don't immediately see a better way to like deal with placement. Like I think that makes a lot of sense.
Okay. Here's a thought I just had, just to entertain it. What if in the Ceph cluster CR, when you're defining a list of storage class device sets, right? Instead of using the storage device set struct directly, you create a wrapper struct, name to be determined, that is storage class device set struct, and then resources and placements as, or rather, storage class device set struct inline, and then resources and placements as separate fields. So that for this struct, which is generic across Rook, we don't do resources and placements, but when we're defining OSD stuff, we do.
Oh, I see. I mean, talking about PVCs, I can see the need to have placement for those. I mean, like you said, different, availability zones and things.
Right.
I mean, I'm a little less convinced about resources, but that's not something I want to dig up again.
And then one thing I'll note about placement is that you can't do affinity. I don't believe you can do affinity on PVCs. You can only do that on pods.
Yeah, pods and nodes, I think, to my understanding.
Yes. So if you wanted to control the placement of where PVCs land in your storage cluster, you would need to have them associated with some kind of pod anyway, even if it's just, a dummy pod that doesn't do anything other than coordinate placement.
Right. And okay, so there's no way to say I want this PVC in this availability zone.
Exactly. And then the resources would come into play because of when it comes time for Kubernetes to do what's the word I'm looking for? Resource balancing. So like if the resources on the node start being consumed beyond capacity, Kubernetes has an algorithm for determining which nodes or which pods it will start evicting first. And the lowest tier citizens in that are pods that don't have any resource requirements. So in the case that a node starts getting full up on resources, any pod that does not have resource requirements would get evicted first. And that means the PVC goes with it.
Okay, so the PVC would go with it. Would the PV go with it as well?
Yes.
Yeah, they're bound together, right? PV and PVC.
Yep.
Okay. I mean that seems, at least from a Ceph sort of failure perspective, like a potentially bad scenario. Like failing a pod isn't really an issue, but if that PV gets destroyed, then that data is lost permanently.
See here. Oh, clarification. Goes away doesn't mean the PV gets destroyed. It merely gets detached from the node. The volume would still exist. The volume would still exist. It would just need to get reattached to whatever node the pod finally lands in.
Okay. Then, and that matches what my mental model was before. Okay.
And one thing maybe that is important for the crush map for device sets is that when we have failover and a pod starts up on a new node, we don't want the crush map to start rebalancing things because an OSD showed up on a different node. We should put OSDs under device sets, and hopefully we can avoid the whole notion of host in the crush map for these OSDs. Right? Otherwise, we get data moving around when the OSDs move to another node.
Yeah, that'd definitely be possible. We could definitely have a fine-grained control of what is defined in the crush identity of a particular OSD. And if we just omit hosts and go with, into cloud region and zone, then rebalancing wouldn't happen, if I understand correctly.
Right. Well, and maybe we add a layer to that, which is the device set name. Right. Maybe we could pretend that's our host, for example.
Not a bad idea. We do have to name them uniquely anyway.
Exactly.
Does anything in this PR or anything in Kubernetes allow you to? I mean, this seems like a sort of affinity thing, where, like, ideally, all of the pods that are created as part of a device set will have anti-affinity with each other so that they are spread across the largest number of nodes as possible.
Correct.
To handle a node failure, which isn't permanent in this design, but I think it may have been you that was mentioning that in AWS it sometimes takes like several minutes for a node to like actually come back online and be ready.
Yeah. Another thing to note with pod anti-affinity, as I understand it, so when you're specifying affinity, there are two types. No, there are several types. One is requested during scheduling but ignored during runtime, or something. The next one, preferred during scheduling but ignored during runtime, required during scheduling but ignored during runtime, and required during scheduling and required at runtime.
Right, and I think you would want preferred during scheduling, ignored during runtime.
Yes, and I believe that is, if I remember correctly reading this somewhere, I believe that is the only mode supported for pod anti-affinity. What this means then, if for instance you have 3 pods, pod 2 or 3 pods on 3 nodes, node 2 goes down, pod 2 then gets scheduled on either node 1 or node 3 if that's the full set of available nodes. So now you have 1 node with 2 pods. When node 2 comes back up, pod 2 will not be rescheduled back on node 2 unless you delete it manually. So there is no automatically rescheduling once the topology of the cluster changes or resolves. With pod anti-affinity, that is. So that's something to keep in mind. That would probably be okay to implement as automation in the operator. It would require some careful thought, but we could do it, I think. And maybe not for an initial implementation. You know, it could be something we leave for future work.
Yeah,
Right. And maybe we just require it. Maybe we just require it to be specified in the CR if that's what they want. And maybe all our examples say, here's how you'd use it.
Yeah. All right.
Okay.
All right.
So now I believe it's been an hour and 19 minutes. At this point, I won't necessarily say, are there any further questions to be answered here? But are there any further questions or topics we would want to make sure get covered offline? I already have my list of 3 items to do. Are there any things anyone else would want me to follow up on or someone else to follow up on? Doesn't sound like it.
I think that's good.
All right, as a final note, this meeting was recorded, so once it is available, I will link it in the design PR for anyone to review. All right. Thanks a lot, guys.
Thanks, everyone. Great discussion.
Bye.
Talk to you later.
Bye-bye.